Sets. So we're going to read the definition on what is a set. So a set is a collection of objects whose contents can be clearly determined. So the symbol for having a set, it's most of the time capital letters. Then you can have the equal sign, and then you can actually have the curly bracket that represent a set, and then you can write the elements inside the set. So something like this. So the next word that we have to know, elements. So the 1, 2, and 3 are the elements of the set S. So elements or members are the object in a set. So that's the definition. Next, we have to know how are you going to represent a set. So this is just an example. It says here, write a word description of the set. So this is all about the first 5 presidents of the United States inside set P. And then we have two format or notation for sets. So the first one is using the raster method. And when you do the raster method, you actually use the braces again, or the curly brackets, and then you separate your elements inside your set with commas. So you can see there are commas here in between. So this example, it says set C is the set of US coins with a value of less than $1. So you can have the penny, nickel, dime, quarter, and half dollar. That's the 50 cent. So that's using raster method. The second notation would be the set builder notation. So I want you to look at the format. So we have that here. And easy to follow also. You can see this is labeled. So when you say W, that's set W. The equal sign actually is the word is. And then you have the set of, because of the braces or the curly brackets. And then the first X here represents all elements of X. So that means that's the variable that we are using. And then the vertical line means such that. So that's the word that you can use, or in other textbook, this is the word given. So you can say all elements X such that, or you can say all elements of X given X is a day of the week. So that's how you use the set builder notation. Okay, look at that one more time. So you need to know how to use and write the raster method and how to write in set builder notation. So we can have an example here for set builder notation. Another example. Now, if you have here set builder iteration, it says all elements of X such that X element of natural numbers and X less than 4. So the raster method that you can do here, this is the equivalent one, less than 4, and it's natural numbers. Natural numbers are like counting numbers that you don't have negative values. So we start with 1 because that's less than 4. That's the first element. Then the second one is 2, and then 3 because that's less than 4. So that's the raster method. So the first one it's in set builder, and then the second one is the raster method. So try to see the difference between the two. Next, we have the empty set, and I think most of you are familiar with empty set. So we have the term null set also, so that's otherwise known as null set or empty set. And you can see you're using the braces again, and if there's nothing inside, that would be the empty set. Or you can have like a circle with a forward slash, and that represents also an empty set. But for example, I have to write something like this, and I have an element inside, which is the symbol for an empty set. Now, this one is not an empty set. So I'll just make a note here. If you put the two symbols together, then that would be not an empty set. You can only use the braces with nothing inside, but if you put anything like a symbol, numbers inside, so that means that it's not an empty set anymore. Okay, so just watch out on that one. So next would be the membership, which we already use the symbol for an element of a set. So this is the element of a set, the other one not an element of a set. So that would be the two symbols that we need to use for setting a membership. For example, I will say 1 here. I'll use the symbol element of, then I have set here. I have here 1, 2, 3. So is it true or false? Our answer here is true, since 1 belongs to the set. If you're going to put like the symbol braces outside 1, and then use the same symbol, and then put 1, 2, 3 on the right side. Now, remember that symbol would mean set, not element. So your answer would be false in that case, because you put the braces that's actually now a set. So 1 is inside that set, so which is not an element. So that would be now false. Uh, Otherwise, it will become true if you're going to use the symbol like this. So if you use that symbol, then it becomes true. Now, we mentioned a while ago about sets of natural numbers. It's like counting numbers. So here's the definition. And note that there would be the term, the three dots. It means that it's continuing. So it's like going to infinity, going to the right. So from the smallest value 1, and it's going to go 6, 1, 2, 3, 4, 5, 6, 6 after 5, and then 7, 8, 9, 10, 11, 12, 13, and it continues to bigger or the biggest value, which is infinity. So that would be the set of natural numbers. It's like counting numbers, but that's a lot to list down. So by using the symbol ellipsis, three dots, it means it continues. Okay, so let's look at the example. So let's take the first example. Let's say you have to express each of the following sets using raster method. Set A is the set of natural number less than 5. So we mentioned that a while ago. I gave you one example already on this, and it says less than 5. So it means you start with the smallest value, and you can see 1, and the biggest value here is 4 because of the condition is less than 5. So this is all about knowing the symbols and knowing the definition of each of the symbols. So now let's go to cardinality and equivalent sets. So I'll give you a chance to read what is a cardinal number and how are you going to find a cardinal number. Okay, so we have a symbol n to represent the cardinality of your set. So A here is a set. So if saying the cardinal number of A, so just count elements of A actually. So that's what it means. So if I have set A here equals to the one that we did a while ago, 1, 2, 3, and you're asked to find the cardinal number, and then your answer would be, I used that one there, n means the cardinal number of A equal to, you just count the number of elements, and it gives you 3 here. So, you know. Okay, next would be the, say set A to set B means that set A contains the same number of elements for equivalent sets. So it doesn't matter what's the content of A and what's the content of B, as long as they have the same number of elements, then the two sets are equivalent. So it's like if I have A here, and then I have here 1, 2, 3, and then set B, it's A, B, C. Then if we're going to think about cardinality, cardinality of A, uh, that would be 3, and cardinality of B, still 3, because you're trying to count the number of elements inside the set. So it means that they are equivalent. So the two sets would be equivalent. A is equivalent to set B. Or okay, counting number of elements inside. So that's what it means. So we have the word one-to-one. So if you're looking at what we did a while ago, it should be one-to-one correspondence. It means that 1 goes to A, 2 goes to B, and 3 goes to C. So that would be the one-to-one correspondence. And the two sets would be equivalent. Now, in the second definition, if there's no one-to-one, now then A is not equivalent to B. So it means that the number of counts or the number of elements inside set A is not equal to the number of elements in set B. So I want you to look at this one here. So this one refers to the one-to-one correspondence. This one. But this one is not, right? So you have twice for Poland and Italy. It's not one-to-one. So that's an example. Okay, so let's go for finite and infinite sets. So I'll give you a chance to read the definition. So for finite set and the infinite set. Okay, so you can see obviously from the definition that when you have the finite set, if the cardinality is equal to 0, so that's an empty set, right? Or if the cardinality is a natural number, we know what's natural numbers, like counting numbers, is start with 1. So that would be finite set. And then if you're looking at infinite set, the set whose cardinality is not a 0, so it's the opposite, or the natural number is called infinite set. Okay, so that would be like continuing, right, up to the positive infinity. It's getting bigger and bigger. Okay, so let's go to the last part for this basic set concepts. So equal sets. Now, when will be the time that we call the two sets are equal? So we have the definition. I'll give you a chance to look at the definition for the equality of sets. Okay, so note that it should be exactly the same elements. So that would be the requirement to become an equal set. So a while ago, when you say equivalent, it doesn't have to have the same exact elements on the two sets. So here you have to have one. So if A here, let's say have 1, 2, 3, B can be 3, 2, 1. So it means that they have exactly the same. So if you're going to look at here, 1 is right here, and then 2, and then 3 is right here. So it means they have exactly the same elements. So then A or set A is equal to set B. So that's actually the definition. But take note, it says possible repetition of the elements. So it doesn't matter. So you're not counting the number of elements now. So if you have, let's say, 2 threes or 3 twos, it doesn't matter at this point. So still they are equal as long as all the elements would be in the other set also. Exactly, same elements. Okay, so this is the basic set concepts. So what we can do here is remembering the symbols and the meaning of each symbol and knowing the raster method, how to write that out, and the set builder notation.